Good morning, trigonometry. We're looking at concept 2.2 today in our notes. Title is Trigonomic Functions of Non-Acute Angles. First, we're going to talk about a reference angle. This is a positive acute angle made by the terminal side of angle theta and x-axis. Key words here. It's got to be an acute angle, smaller than 90 degrees. Terminal side. Remember, this has to start with the side touching the given theta angle. And of course, the x-axis. That is very important. Notice there is a little typo. It should be theta with a prime, a little apostrophe. So I'm going to go over the theta in red. I'm just going to color over it. So you'll see that pop up now. And I've even drawn the direction. Remember, we always go counterclockwise. And then I'm going to draw in what our reference angle would be. I'm going to do it in blue. So there they are. Notice that they are all sharing the terminal side with theta. And they also touch that x-axis. And the last big thing is they are acute. None of them are larger than 90 degrees. So now we're actually going to start finding reference angles. I've given you some steps listed out above. Step 1, find the coterminal angle between 0 and 360 if needed. This is only when you have an angle that's larger than 360 or smaller than 0. You'll see in example B, we will have to do this step. So for example A, we do not need to do this step. We can go ahead and skip to step 2, which is draw a picture of the angle to see its quadrant location. So there I've drawn it. I know it's in the third quadrant because I know going down at like 6 o'clock would be 270. So it's got to be between the x-axis and y-axis in the third quadrant. And now I'm going to kind of draw in what my reference angle would be. Remember, it should be acute, should share terminal side, and touch the x-axis. Q3, so there it is. I know Q3 is where my reference angle should be. And step 3 is find the quadrant of the angle and the difference between the angle and 180 or 360. So it depends here. Here I know that the theta is taking up a half circle and a little bit into quadrant 3, which is the part that's theta prime. So I should be taking 180 and subtract from it. Sorry, take the theta and subtract from it 180. I need to subtract that half circle. That's going to give me 38 as my reference angle, theta prime. All right, moving on to B. So I said we would have to do step 1 for B. 1,387 is much larger than 360. So I'm going to take my 1,387 and divide it by 360. When I do that, I'm just rounding up to a decimal place. It's about 3.8. That 3 is going to tell me how many times I should subtract 360. You could just keep subtracting 360 until you get a number that's smaller than 360. So I subtracted it 3 times and I get 307. So now 307 is the number I am going to be using as my theta. I kind of did a bad job of writing out my steps here. So step 2 I'm going to actually draw a picture of the angle to see its quadrant location. Again, 307, that should be all the way in quadrant 4. Remember, counterclockwise. So drawing in my theta prime, or my reference angle, I know it should be acute, touch the terminal side, and the x-axis. So that tells me it is that purple area to the right that's not filled in. Now it's in blue. So finding theta prime, I'm going to take 360 and subtract from it my given angle, 307. So I can see it's a full circle, and I should just subtract out the reference angle portion. When I do that, I'm going to get 53 degrees. So please take a minute to pause your video and work through C and D. Come back to check your answers when you are finished. So here I have found for C, the actual reference angle must be acute and touch that terminal side as well as the x-axis. So therefore, the reference angle is the given angle to us, the theta, 65 degrees. And part D was kind of similar to part B, but I didn't have to do step 1. I found that it's a small portion in quadrant 4, so 360 minus 300 gives me 60 degrees. So we are going to use our reference angles. We didn't just learn about them for nothing. We can actually use reference angles to help us find exact trig function values for angles of 30, 60, and 45 degrees. Pardon me. The reason we can do that is because we have special right triangles. We learn these in geometry, you learn them in middle school, but here they are. I've drawn them. I printed them, I didn't draw them. Give you some arrows to kind of point at you. There we go. There's my special rights. So we're going to first find the coterminal angle between 0 and 60. We're going to draw a picture of the angle to see its quadrant location and find its reference angle. Make sure you're checking to see what quadrant it's in, because all students take calculus, all students take, I don't remember what Miss Backus said, but that was the one I remember from school. Your positive and negative signs, then use your right triangles to find the exact values. Alright, so examples for 210 and 675. On your notes, you should see the steps still listed above. Obviously, I cannot see those on my part. I'm on a PowerPoint. So we need to find the exact values of sine, cosine, and tangent for 210, example 1. Step 1 says find a coterminal angle if needed. Well, 210 is between 360, so I do not need to do step 1. Step 2 is to draw a picture of the angle to see its location of the quadrant. 210, okay, I can do that. It looks like it's in quadrant 3. I'm going to label my all students take calculus. We're in quadrant 3. I've drawn in my reference angle in red. So just like the last problems we did, I need to actually find the value of the reference angle. I know I should take the 210, subtract from it 180 to give me 30 degrees. 30 degrees is super important. That tells me I've got my special right triangle I can use, 30 degrees. Check your picture. Make sure you label everything correctly. Square root of 3, 1, and 2. And now I'm going to find my sine, cosine. Oops. Before that, we're in quadrant 3. Remember, that's only where tangent is positive. So I need to make sure I have my negative signs on my values. So I went to the left on the x-axis, so square root of 3 should be negative. And I went down on the y-axis, therefore my y value of 1 should be also negative. So that is. So now I got to find my sine, cosine, tangent. Remember that sine, opposite over hypotenuse. So I drew in the arrows in blue, -1 over 2. Cosine is adjacent over hypotenuse, square root of 3 over 2. Negative, remember that. And tangent would be -1 over the negative square root of 3. We need to rationalize our denominator, give us square root of 3 over 3. So we have just found the answers for cosine, sine, and tangent of 210 degrees. Now we need to do it for 675. This is larger than 360, so I'm going to have to subtract 360 to find that coterminal angle. When I do that, step 1, I get 315. Step 2, I gotta draw it. Oh, let me change it first. There we go. So I've drawn it in. It should be in quadrant 4, where only cosine is positive. My reference angle is that small in red, theta prime. And if I'm in quadrant 4, I know I need to be taking my 315 and subtract from 360 the 315. I just need the small part left of the circle, full circle, 45 degrees. So I've now got my special right triangle. I can draw that in. 45 degrees, -1. Remember, it's -1 because I went down on the y-axis, and only cosine's positive here. And now I can find my sine, cosine, tangent of 45 degrees. So sine, opposite over hypotenuse, -1 over square root of 2. Gotta rationalize. Same with cosine, but this time cosine is positive because we're in the fourth quadrant and 1 is positive. making our tangent last of -1 over 1, which is -1. For the next two examples, again, please pause the video, try it on your own, and come back to double check to see if you got it correct. So there we've found 45 degrees as the reference angle for 135. And for 60 degrees, well, the reference angle is itself 60 degrees. For the last section for this notes, we're going to find the angle from a given trig function. So we're kind of working backwards here. We call these inverse trig functions. So before we actually just use those in a calculator, we want to kind of understand how they work. So we're looking backwards. First, we're going to look at the ratio and determine if the special angle or special triangle is the 30-60 or the 45. We'll draw that triangle and label, and then we're going to work backwards to find out what that angle measure is. And we will draw it on the x and y axis, or on a coordinate plane, and find the other angles if we need. Alright, for these examples, we are going to be finding all the values of theta if theta is between 0 and 360 and has the given function. So let's get down our special right triangles, and I put the all students take calculus breakdown positives and negatives there. Sine of theta equals 1/2. So I need to first determine what special right triangle I'm working with. I've got 1 and 2 in those in the sine value. So that should tell me immediately I'm working with my 30-60-90 triangle. So I'm going to draw out that triangle. And there we go. And I know that I am using 1 and 2, opposite over hypotenuse. So opposite, and I need to get 1, should be 30 degrees. And 2 is hypotenuse, so it has to be across from 30. I know that my sine value is positive, so that tells me I should be in either quadrant 1 and quadrant 2. So from here, I can kind of figure out, I know my first angle, if it's in quadrant 1, it has to be 30 degrees. And then my second angle, if it's in quadrant 2, I should take my 180 and subtract from it the 30 degrees to give me 150. Last step here is to draw, and in the next problem, I'm actually going to draw it and then find the angle. So step 3, there it is. 30 degrees is an easy one to draw. It's just the angle, 30 degrees. And in my step 3 directions, it tells me in quadrants other than quadrant 1, list it as the reference angle. So I've drawn it just as the reference angle and also labeled it, but that would be 150 degrees in the large angle. Okay, moving over to number 2, cosine of theta equals negative square root of 3 over 2. Determine first which special right triangle you're working with. I know I've got a square root of 3. That immediately tells me I'm still working with a 30-60-90 triangle. I've drawn it in. Remember, cosine is adjacent over hypotenuse, so I need to find the angle that's adjacent to root 3. Remember, it's negative root 3 as well. So adjacent to negative root 3 has to be the 30 degrees. So that tells me since cosine is negative and we're using 30 degrees, this should be in quadrant 2 or quadrant 3. So I'm actually going to draw those out and then I'm going to find them. There should be a theta prime on that green one. But these are both reference angles because they are not in quadrant 1. If I know my angle, my reference angle is 30 degrees, and looking at the left drawing there, I know I should take the 180 and subtract from it 30 to give me the first angle. Oops, I did both of them, that's okay. So 180 minus 30 is 150. And then this is a little different, you kind of have to think, problem solve a little bit. I know that I'm 30 degrees into the third quadrant, so the first two quadrants would be 180. 180 plus the 30 would give me 210. Alright, for number 3 and 4, please pause, work them out on your own, and come back to double check your answers. I will do 5 and 6 working through it through the video. So here are your answers. Alright, our last two examples, we need to find that theta, or multiple thetas. Given that tangent of theta is equal to -1, first identify what your special right triangle is. Well, I've got -1 as the value, so it's got to be the 45, 45, 90. And it's negative, so that tells me that either one of those ones is negative. So from here, I can go ahead and sketch. I know it's going to be in quadrant 2 or 4 because tangent is negative. And now I can sketch those angles. They are both reference angles because they are in quadrant 2 and 4. Only quadrant 1 would be a general angle, not a reference angle. So to find those values for the first angle on the left, I know that it's part of the half circle on the top. So I'm going to take 180 and subtract from it 45 degrees. That gives me 135. And then I know my angle on the right is just that little portion. So if I took 360 and subtracted from it 45, I'm going to get the entire reference angle, 315. Moving on to 6, secant of theta. This one is important because we haven't talked about secant yet. We've only been doing sines, cosines, and tangents. We know that secant, though, can be rewritten. It's 1 over cosine. So I can take what secant is equal to and take the inverse of it. So cosine of theta would be -1 over root 2. Gotta rationalize that, and it's square root of 2 over 2. Looking at square root of 2 over 2, that doesn't help me with my special right triangles. So actually what you're going to want to do is use that first, before you rationalized. -1 and square root of 2, I know both of those are side lengths in the 45, 45, 90 triangle. So that's the triangle I will be using. My cosine is negative, so that tells me I should be in quadrant 2 and 3. I've drawn my right triangle out. So when I put them in the quadrants, they are going to both be reference angles because they are not in quadrant 1. So again, for the left angle, taking 180 and subtracting from it the reference angle, which was 45, which gives me 135, and in quadrant, oh, I drew that one incorrectly. Let me correct that really quick. All right, now I have fixed it. It should be in quadrant 3. So we take the 180 and we add to it 45 to give me 225. Feel free to email me with any questions if you've got it. Now direct your way to work on the homework.